and then we'll look at calculus to figure out how we can curve sketch without having to use special techniques for all the graphs. Because up till now we've learned a whole bunch of special techniques. What about lines? Y equals mx plus b. You know y-intercept and you knew slope, and then you could graph a line. Parabolas. What are some things you remember about parabolas? Yeah, if we could write it in the vertex form, then you know where the vertex is, and then that a value told you a little bit about how much it was increasing, you know, over 1, up 1, over 1, up 3, and so on and so forth if a value is 1. So we had some special techniques for that. How did we get it in that vertex form? Complete the square. First step in completing the square. Take out the 3, because that's going to match up with our a value. Do you agree that this is still equal to what we had before? Now, if we were going to write this as something squared, you would need a number in here. Okay? Does it make sense that that's going to have to be plus 4 in order to get this to be x plus 2? Some patterns you may remember from factoring perfect squares or expanding perfect squares. This number and this number are always related because that's divided by 2. And then this number to this number are always squared. So you might have remembered as a sort of a shortcut that all I need to do to this 4 here is divide it by 2 and then square it to get this other number. But as soon as I add that blue 4 there, that no longer makes my equation equal. You can't just add something to one side of an equation, because then you create an unbalance. So if I add 4 here, what would I have to do in this blue line to make sure that I counteract that? Subtract 12. Because everybody knows that adding 4 is the same as subtracting 12. Why is it 12? Because it gets multiplied by that 3. Technically, with this 4 inside the brackets, it is getting hit by that 3 in front. So even though we wrote plus 4, we actually added 12 the first time. So in order to compensate for that, to cancel it out, we have to subtract 12, and then we've changed its form to y equals 3x plus 2 squared minus 13. And once you have it in that form, you remember way back from grade 11, now we know the vertex is at negative 2, negative 13. So you would know that value. You would know from this 3 out in front that you would go over 1, up 3 in both directions. So you would have negative 1, negative 10. Then over 1, up 9. And you would have 0, negative 1. You could also find 0, negative 1 because that is your y-intercept by just plugging in 0 for x. And in the original equation, that comes out really clearly that it's negative 1. So there we were able to use some of our old techniques to get this as our graph. Calculus will tell us some new techniques as well. For one, we're going to use this idea that we saw before, that if we wanted to find that vertex on a parabola, the vertex is the only place where the tangent is flat, where it's horizontal, and then its derivative will be 0. How hard is it to take the derivative of the function we had to begin with? Not very hard at all. Y prime will be 6x plus 12. How hard is that to figure out when x will equal 0? Not hard at all. You get x equals negative 2. Pretty negative 2. Plug that negative 2 back into your original equation, and you would get this vertex just about as fast. Maybe faster. So we know already that all of our derivatives that we do are about slopes of tangents. And those slopes can tell us a lot about the graph. On that blue sheet that we just worked on, we use these ideas. When I put idea number 1 was whenever the derivative is 0. What did that mean? In order to have a horizontal line, your function has to either reach a maximum or reach a minimum. This part here, if f prime of x is greater than 0, in other words, this is saying when the derivative, which is the slope, is positive, what does that mean about our original function? And we saw this before. That means that our original function was increasing. And where our derivative, our slope of our tangent is negative, that means that our original function is decreasing. So now we've already done this already. Using calculus to find the vertex, we'll just write it again. If we find our derivative, set our derivative to 0, because that's when it's going to have a max or a min, and a parabola, in this case, will have a minimum. We can solve that x is equal to -2. Move the 12 over and divide by 6. Then if we want to find the actual point, remember the vertex is on our original graph, and this equation is our original graph. This just tells us our x-coordinate. The one thing that you're going to have to focus on is there's going to be times that you're going to want to plug -2 back into the derivative, and there's going to be times where you want to plug the -2 back into the function. So one thing to ask yourself, well, what point am I trying to find? Am I trying to find something that the derivative is telling me, or am I trying to find something that's on the original function? And the vertex is on the original function, so I'll plug in -2 into my original function. And then I'll find my vertex to be -2, -13.